Greetings, ladies and gents, and welcome back. It's Mike Medicines Club. Today we'll be looking at a question which was written in November 2019. I sourced this question from Stanmore Physics. It's quite a nice website with a lot of good resources. So I would actually recommend that you use that website. I know it's written Stanmore Physics, but I can promise you that it's not only physics that you find there. There's also maths, life science, computer application technology, and there are many subjects there. So yeah. So in this case, what we'll be doing in this case would be question 2, which is actually on Newton's laws. So this is also relevant for the grade 11s and also grade 12. So they're saying that block P of mass 2 kg is connected to block Q of mass 3 kg by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. They say that block Q is pulled by a constant force of 40 Newton at an angle of 25 degrees to the incline. They say that block P moves on a rough section AB. So what they're saying is that section AB is actually a rough surface, meaning that we also have a friction between those 2 points. They say that while block Q moves on a frictionless section BC, so again they're saying that that part BC, that section BC, there is no friction. So they say that, see the diagram below, an average constant frictional force of 2.5 Newton acts on block P as it moves from A to B up the incline. Now I know I know it's annoying, ladies and gentlemen, to read that essay that we have up there. But unfortunately, there's nothing we can do. We need to read that statement. Reason being, what the examiners do is that they actually hide, some of the information in those paragraphs. As you can note, that they didn't actually show the frictional force, but the value of the frictional force. But in this case, like they did for that force applied there. But in this case, they actually told us that the value of the constant frictional force to be 2.5. So in this case, for 2.1, they said that state Newton's second law in words. So I'm not gonna write that down, unfortunately, but I'm just gonna say it, and of course you can write it down. They said that state Newton's second law in words. So what Newton's second law simply states is that when a net force acts on an object, that object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. So that's Newton's second law of motion in words. It says that when a net force acts on an object, that object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. So that's for 2.2. So for so that was for 2.1. So for 2.2, they say that draw a labeled free body diagram for block P. Now, what I mentioned in this other question which I did, which was written in November 2022, if I'm not mistaken, I mentioned the fact that whenever they ask for a free body diagram, you must always give them the one does not have components, right? So if you have, let's say, force acting at an angle, you mustn't resolve it. If they ask for a free body diagram, you must just give them the one without components. So in this case, for block P, so in this case, we know that what we have, let me just take my pen there. So what we have acting on that block, we have the tension. Let me just make that a little bit bigger. So we have tension, all right, acting in that direction. We also have friction. They say that's a rough surface, right? So we have friction, Fk, all right? But we also have normal force, which is always perpendicular to our surface, and we also have the force of gravity. Now remember that the force of gravity is always vertically downwards, so gravity does not actually care whether you are moving up at an inclined surface or on a horizontal surface. So the force of gravity is always pulling the object vertically downwards. So in this case, our force of gravity would actually be in that dimension there. So that would be our Fg there. So this would be the type of a free body diagram that you would actually give them if they ask for a free body diagram, the one without components. But whenever you are actually, when you are going to perform your calculation, you would actually need to use the one with components. So you would need to resolve your forces in this case such that they are in the in the vertical dimension or in the horizontal dimension. So in this case, you would need your forces to either be in this dimension or in that dimension. As you can note, that fj is not actually either in that dimension or in that dimension there. So this would actually be for your own good for the calculation. So in this case, if they ask for a free body diagram, this would be the type of a diagram that you would actually give them. So in this case, for 2.3, they say that calculate the magnitude of the acceleration of block P while block P is moving on section AB. Now, as you can note that here we actually need to do some calculation. That's a 8-mark question. So in this case, what I'm gonna do, what you would need to do is that you would need to draw another free body diagram, the one with components, either on a question paper. It really doesn't matter. So in this case, what I'm gonna do, I'm actually just gonna resolve that FG such that it is either in this dimension or in that dimension there. Now, whenever you are resolving FG, you're going to have FG perpendicular and also FG parallel. Now, one thing that you must notice that FG parallel will always be acting down the incline, always. So in this case, what you're going to have FG acting in that dimension. So you would have FG parallel, and you would also have FG. What am I doing now? So that would be FG perpendicular. Now to calculate FG perpendicular, so to calculate FG parallel, so you'd actually say FG. Let me just write that in a simplified way. So you'd say mg sine of theta. So in this case, this theta would be, of course, the angle between our inclined surface and, of course, in that horizontal surface there. So in this case, it would be that 30 degree. So in this case, for FG perpendicular, so it would be, of course, mg sine. Actually, it would be cos in this case. So in this case, it would be cos of angle theta. So that's how you would calculate your FG parallel and your FG perpendicular. So in this case, what I'm also gonna do is that I'm also gonna draw a free body diagram for that block Q, and you will see why I'm gonna do that. So in this case, if I draw a free body diagram for that block Q, I'm just gonna use another color. So in this case, what I would have is that I would have that force. Now remember that 40 Newton is actually at an angle. So again, I would need to resolve it. So in this case, what I would have F parallel and F, that looks like an R now. So it would be F perpendicular. So also now remember that we also have normal force. So in this case, we would also have the normal force. But remember that we also have the force of gravity and also that tension. Now in this case, what we also have in this dimension, we also have tension pulling that object, that 3 kg block down the incline. So in this case, we also have the tension acting in that dimension. We also have tension, but remember that we also have the force of gravity. So in this case, we would need to resolve that force of gravity. So what we would have in this case is always we would have FG perpendicular and FG, it would have FG parallel and, of course, FG perpendicular. So that's what we would have there. So in this case, one thing that you must notice that whatever acceleration that we find using that block P would actually be the same acceleration that we would find if we were to use that block Q. Now the reason for that is that those two blocks, now remember they said they are connected by a light inextensible string, right? So if this block Q is accelerating at let's say 2 meters per second squared at an acceleration of 2 meters per second squared. So that would also mean that block P would also be accelerating at that same value, with that same value. And one also another thing that you must note is that whatever tension that you would find using that block Q, it would also be the same tension that you would actually find using that block P, right? So what I'm gonna do is that I'm gonna try to find my acceleration using that block Q and see what I can find. So in this case now, remember that our our block would be actually accelerating in this dimension that we have here. So what I'm gonna do is that I'm gonna say I'm actually just gonna use Newton's second law of motion, which says that F net, is equals to ma. Now remember, when you say F net, we are saying we're actually taking the sum of the forces that are in a particular dimension. So in this case, it would either be in this dimension or in that dimension. Now in this case, now remember that our object is actually accelerating in this dimension. So in this case, if you're looking for the acceleration of that object, would actually be using the forces that would take the sum of all the forces that are actually acting in that dimension, these two dimensions. So what I'm gonna do, I'm gonna try to find my acceleration using that block P first and see what I come up with. So in this case, this would be when I use my that block P. So in this case, let me just use another color so that I don't make confusions. So let me just erase that. So in this case, what I'm going to say F net is equals to ma. Now remember, we said that our system is actually accelerating in this dimension that we have here. So in this case, what I'm going to do, I'm going to take the sum of all the forces acting in that dimension. So what I would have in this case, I would have, now I'm going to take up the inclined as positive. So that would actually mean that my tension would be positive. So that we have tension minus Fk minus Fg parallel. So that would actually be equals to ma. Now remember, we said to find Fg parallel, we would say mg multiplied by sine of theta, where m would be the mass and g would be the gravitational acceleration value, which is 9.8 meters per second squared. So in this case, what we have in this case would be tension minus Fk. Now remember, they gave us Fk to be 2.5, so this would be 2.5 minus mg sine of theta. So in this case, we know that the mass would be that 2 kg, so this would be 2 multiplied by 9.8 multiplied by sine of our of that 30 degrees. So that would be a 30 degree. That would actually equals to 2a. Now remember that a would be the acceleration and that 2 would actually be the mass of our object. So in this case, if I simplify this, of course, combining that this if I take negative 2.5 and I add and I subtract that 2 multiplied by 9.8 minus multiplied by sine of 30. So what I would have in this case, so it would be negative 2.5 minus 2 multiplied by 9.8 multiplied by sine of 30 degree. So what I would have in this case would be negative 12.3. So I would have tension. So let me just take that again. So this would be tension minus 12.3. So this would actually equals to 2a. Now what I'm going to do is that I'm actually going to take I'm actually going to let that t being the subject of the formula. Now you will see why I'm actually just gonna do that. So in this case, we would have t being equals to 2a minus, so it would be plus 12.3. Now this would be the equation that I would have if I were to to calculate, let's say, tension, if I were using that block is it I think, yeah, it's block P. Now remember, I said that whatever tension that you would find using that block P would actually be the same. You would find the same tension that you would actually get, let's say, if you're using that block Q. And whatever acceleration that you find using block P, it would actually be the same if you were using that block Q. So what I'm going to do now, since there's nothing I can do any further because I don't know what T is, right? In this case, I'm trying to find A. So what I'm going to do, I'm going to try to find that acceleration again using that block Q now. Now what I have, now I'm going to use the same law, Newton's second law. I'm going to say F net. Let me just scroll that. So in this case, I'm going to say F net. Let me just write that in another color again. So in this case, I'm going to say F net is equals to MA. Now remember that, of course, our object is still accelerating, of course, in this dimension that we have here. So in this case, I'm going to take the sum of all these forces that I have here. So in this case, I would have F parallel. So I would have F parallel minus tension minus Fj parallel. So in this case, that should be equals to MA. So in this case, to find F, that F parallel, that force applied parallel, let me just write that as FA. So in this case, it would be actually F A multiplied by sine by cos of theta. Now remember, this theta would be this angle that we have, that 25 degree there. So in this case, this would be minus tension minus mg sine of theta. Now remember, this theta and that theta, they're not actually the same. So this theta, of course, that we have for mg sine of theta, this would be this that 30 degree, and then the one that we have, the theta, the for fa, force applied multiplied by cos of theta. So that theta there would actually be the angle between our force and then, of course, between this surface that we have here. So it would actually be that 25 degree. So in this case, what I would have would be the force, which is 40. Let me just scroll that up so that I have somewhere to write. So in this case, I would have 40 multiplied by cos of 25 degrees minus tension minus, in this case, now remember, I'm using that 3 kg block, so this would be 3 multiplied by 9.8 multiplied by sine of 30 degrees. So that should actually equals to the mass, which is 3. So it would be equals to 3a. Now what I'm going to do again, I'm going to take these values, and then I'm gonna find, I'm just gonna put this in my calculator and see what the answer that I'll come up with. So what I'm going to do, let me just pull my calculator out. So in this case, what I'm, let me just, okay. So in this case, I have 40 multiplied by sine, by cos, rather by cos of 25 degrees. So that would be minus 3 multiplied by 9.8 multiplied by sine of 30 degrees. So in this case, what I have is 21.552 311. Let's see if I can just write that. Now I'm making a mess. So that's, so in this case, what I have, that's 21. So in this case, we have, so that's 21.5523. So we, let me just put that. So that's 21.55231. If I'm not mistaken, I'm just gonna keep 2 5 decimal places later. Now you can keep all of it now again. So if you keep 4, I wouldn't think that it would actually make that much of a difference. So in this case, you would have minus t. So this would actually be equal. Now we can't, the reason why we can't round off early is because this is not actually the final answer. So in this case, this would be equals to 3a. Now what I'm going to do again, I'm going to isolate that tension. So in this case, what I would have, if you do your mathematical gymnastics there, so you would have 21.55231 minus 3a being equals to t. Now, remember I said that whatever tension that you find using that block P would actually be the same tension that you find using that block P and Q, right? So what I'm going to argue is that T, let me just use another color again, so that, so in this case, what I'm going to argue is that T is actually equals to T. This is actually the same tension. So what I'm going to do, I'm going to equate these two equations. So what I'm going to have, 2a 2a plus 12.3. So this would actually be equals to 21.55231 minus 3a. Now I'm going to collect like terms. So in this case, I'm just going to take this -3. I'm going to take it to the other side. Then I'm going to take that 12.3 to the other side. So in this case, what I would have would be 5a being equals to now 12. Now, so in this case, I'm just going to subtract 12 point minus 12.3. So what I have is actually 9.252. So what I have is so that's 9.252 and of course some other decimals. So in this case, what I'm going to do, I'm going to divide by 5 on both sides. So if you do that, let me just put that into brackets. So in this case, if I say divide by 5, let me just put that there. So in this case, what I would have in this case is a being 1.85. So in this case, we would have that acceleration value. So in this case, we would have a being equals to 1.85 meters per second squared. Now remember that acceleration is in meters per second squared. Now remember, they said that they want the magnitude of the acceleration. They didn't actually say the acceleration. So in this case, we wouldn't be concern ourselves about the direction of that acceleration, even though if they ask for the value of the acceleration itself. So in this case, we would need, of course, to consider the direction. So in this case, since it's positive and we chose going up for the incline, it's positive. So in this case, it was going to be 1.85 meters per second squared up the incline. So for 2.4, they say that if block P has now passed point P, let me just scroll up again. So they said that if block P is now past point P, how will its acceleration compare to that calculated in question 2.3? Choose from greater than, smaller than, or equal to. Give a reason for your answer. Now the answer to that is actually greater than. So in this case, the acceleration would actually increase. Now I want you to think of this as, now suppose, let's say you were pulling, let's say, a block, right, that is, let's say, things inside it. Now if, let's say, one of these things that are actually inside that block, now suppose you were pulling that block, that crate, right? So if, let's say, some of the things that are inside the crate falls down, so in this case, what would you actually experience would that you'd actually start to some sort of start moving faster. Why? In this case, because some of the things fell off. So in this case, it's now less heavy, and it says it is less mass. So in this case, now remember that as soon as that block P passes that point B, there is no friction now. So in this case, it would actually start to accelerate. So in this case, the acceleration will actually be greater than. So the reason for that would be because now that section, now since it has passed point B, so that would actually mean that we no longer have the frictional force. So in this case, because that's actually a smooth surface, so in this case, for that reason, the reason would be because there is no friction between point B and C. So that's for it for this question. Of course, if it helped you at some point, give a thumbs up. If you haven't subscribed, please consider being part of the family. But as always, ladies and gentlemen, this is Mike signing out. Sharp, sharp.